In this video, we're going to walk through a solution to one of our practice problems. This one is looking at a crystal that's being analyzed by X-ray crystallography. And we're not exactly sure what it is. We think it's krypton or argon or neon. And we're going to assume it has a simple cubic unit cell. And the question is, given the information we collect from the experiment, which element is it? So we know that we have a wavelength. Oh, I had to switch, sorry. We have a wavelength of 154 picometers, and the reflection angle is going to be 32.6 degrees. We're going to assume that we have a diffraction order of 1 as well. So looking at this, let's put out our Bragg equation here first. So we know that our diffraction order times our wavelength will be equal to 2 times that distance between our lattice planes, sine of that angle of diffraction. So what we really are looking for here is distance, and that's going to give us that distance between our planes. And in a simple cubic crystal structure, we're going to have lattice points at our 4 corners, and they'll be stacked on top of each other like this. So if we know the distance between these 2 planes right here, what we really know, let's get a different color, is if these are our lattice points, they're really atoms around it, and those atoms are arranged until they're touching. And so that distance is really going to be equal to 2 times the radius of one of these atoms. So let's go ahead and plug into our Bragg equation our values that we know and determine what that distance between our lattice planes is. And then we'll determine what the radius of the atoms are that make up this crystal structure. So looking at my equation, I'm going to have a diffraction order of 1. I have a wavelength of 154 picometers. That'll be equal to 2 times the distance times the sine of my diffraction angle, which the max diffraction angle we saw was 32.6 degrees. So now I'm going to solve for D. So that D is going to be equal to 1 times 154 divided by 2 sine 32.6, which will give me a value of 143. And my units here are picometers. They match the unit of the wavelength distance, the length measured in the wavelength. So that's D. I know that D is going to be equal to 2 atoms radius. So I will plug that in and divide by 2. So 143 picometers divided by 2 is going to give me R. That should be equal to about 71.5 picometers. And then looking at our 3 options that we have, krypton's 87, argon is 71, and neon is 38. This tells us that our closest one is argon. So we can assume that we've got a simple cubic arrangement of argon atoms in this crystal.